Back. Okay. So so here's where we write the code. And then here on the left-hand side is what we call the inspector. And the inspector is basically the navigator. And this is where we basically have all of our files. So here we have our project settings. Again, you don't need to worry about this. This is just some settings. And so under this project, settings folder, we have this another folder, and this is where our actual code or files of our project actually lives. So we have these two files that we have right here, and I'll talk about them in a minute. And then we have this default assets folder. And this is where you basically put all of your assets for your project. So if you have cloned it, you already see these dices already put in there. So you could put images in your project as well. You basically drag and drop into this assets folder. You could also, if you want an app icon, you could basically drag an app icon into here. And the requirement is that the app icon is 1024 pixels by 1024 pixels. Okay. And you can also specify a dark variant when the app is in dark mode. Cool. Again, so we have a lot of controls here. This is, again, our files. This is source control. So if you're ever using Git, you could manage your status of files within here. This is the bookmarks. So within our code, we could add bookmarks so that we could keep track of things that we need to do. They show up here. Here's where we could search up text within our file. So let's say I search up content view. Oops, sorry, not the queue. We could see all the instances or matches of content view within our code. Here we have basically if there are any issues when we basically run the project, and if there are any errors, they show up here. You don't need to worry about tests. This is when you have a debug session. It will show here. Again, you don't need to worry about that. Breakpoints, this is when you use for debugging. You don't need to worry about that. Here is basically the build, I believe, the build navigator, report navigator. And this is where you could see all of your past builds or runs of your app, and you could dive into see what's airing. All right, let's go back to our files and let's take a look at the hog starter app file. So this is a very important file because without this file, your app doesn't work. Why is that? Well, this is actually the entry point within your app. How do we know it's the entry point? Because of this at main kind of declaration that we have here. So we basically create this hog starter app, which is an app. And within here, this creates a scene. So a scene in iOS, right? All apps, there's only one instance of your app running, right? So there's only one scene. But on iPad OS, Mac OS, you could have multiple windows. Your app can generate multiple windows, and that's how we can manage. It creates a scene for each window, and we can manage those windows via window group. But again, you don't need to worry about that. The main thing here is that we have this content view right here. What is our content view? Our content view is declared right here. So you could see that this is SwiftUI. Okay, so this is how we write UI. So we declare a view. Okay, a view is always a struct. Okay, this is sort of a data type that we could, a special data type where it has properties. It can also have functions within it. And here we have this colon, and we have after that, it's the view. So this looks like a data type, but it's not. It's something called a protocol. So a protocol, for those who have Java experience, is an abstract interface. And what that means is that basically Apple made this thing called view that basically lists or declares what makes a view a view. Okay, what are the requirements for something to be a view? So here we're saying that content view is or conforms to a view. One of its requirements is this body property. So this body property basically is the actual content of this content view, right? What is going to be shown on screen? Again, you don't worry about the sum view, it's just required. But let's take a look into this code. Here we have, as Dylan briefed earlier about VStacks, this is a container object. A container can contain multiple subviews. A VStack can contain multiple subviews and align themselves vertically. So here we can see we have two subviews, an image and a text, right? So here we can see right on the right hand side, this is what we call the SwiftUI canvas. And this is where we basically can preview our code right within Xcode without running our app. What's driving this canvas is this preview macro. So right here basically gets shown right onto our right. So right now we're basically showing content view. Now I could change this to be a text, right? Um, oops, sorry. And then it will render it to the right. You can see hello. So I'll keep it to content view. Okay, so that is, again, when I change the code on the code editor, it modifies, you could see it render or re-render real time in the canvas. Let's take a look at some controls that we have here. So here is, on the left-hand side, is the live preview. So when we build our app, we can basically interact, we can basically touch, tap, drag this canvas or the iPhone in this canvas. Here is the element inspector. So basically I can tap on elements within my SwiftUI canvas and it will highlight the corresponding one in the code. Um, and if I could do the same thing to the text. And this gives me a great visual representation of the bounding boxes of what's what, right? Here on the right-hand side, the last button is basically variants. So I could see my app in both light mode, dark mode. I could also see my app uh, in different orientation variants. So portrait, different versions of landscape. I could also see my app with dynamic type. So this is an accessibility feature where, for example, a user in settings can change the font size or basically the accessibility type, and SwiftUI, the text view, automatically supports dynamic type, so it scales accordingly. And here are some kind of force canvas device settings just for the canvas itself that you could force it to be. And then here on the right-hand side is basically, you could basically run it or what device you want to show in the canvas. But we're going to keep it to an iPhone for now. Okay. And then here on the right-hand side is our inspector. Again, you don't need to worry about this, but it's just basically depending on what you select, the inspector changes depending on, again, what you select. So for example, when I click on foreground style, this view modifier, I get to see documentation within here. Okay. Now, a great tip is that if you click option click, Xcode will show a pop-up of the documentation. So again, that's option click. All right, so let's take a look at our app and let's take a look at what we need to do. So I'm going to full screen here and I'm going to bring my simulator to our app itself. Okay, so here we're on the right, here's on the left. All right, let's start off with the very basics. So we're going to implement the header first, right? What we see right here. Um, and also we could also implement the background as well. Okay. So, but let's just start with the header first. Okay. So how I like to do this is kind of analyze what views or what kind of like rectangles can I identify and break it up into pieces. Okay. So here on what I see this goal, like this goal number on the left-hand side right here, and I have the player scores on the right-hand side. So what I'm envisioning is that here, right, this is containing with this big rectangle, right? It's a again, you can imagine an invisible container containing all these two sections. This thing could be one part, a subview, and this could be another subview, right? So what we're looking here is that we want to position these two subviews horizontally. And what that means to me is that, hey, I need an H stack. So let's do that. So let's replace this with an H stack. Cool. So now I have an H stack. Let's create the text. So I could just basically, within these curly brackets, I could basically, create this text with goal, and let's just leave it with 100 for now. We're gonna hook it up to the logic later on. Cool. Now, let's take a look at how we implement the second portion or the second subview to the right. Now, we can break this down even further, right? I can see that we have this thing, this player one text on the top here, and this player two text on the bottom. So what that tells me is that we can use a V-stack, right? We have two subviews placed vertically. So I can, within my H stack, I can write a V-stack, right? And this is where we contain our player one and player two scores. So again, these are just text objects. So I'll do player one, 5 for now. And then here, we're going to do player two, 1. And we're going to change these scores based on string interpolation later on. Cool. So let's take a look at our simulator. Okay, we're getting somewhere, but doesn't look quite right. The main thing is that these guys need to be placed far apart, right? There's this separation. Well, SwiftUI has this view called a spacer object. What the spacer object does is that it takes the available space, right, that we had before on the left-hand side and right-hand side, and allocates those available space, so extra space, to that spacer. So now we have that, we put all that available space between these two, between the text and the VStack. Cool. Now let's work on fonts and styling. So here on the left-hand side, we can see it's a bit bolded, right? And also it's a bit bigger as well. So we can use view modifiers to do that. View modifiers are basically mechanisms where we could modify different properties of SwiftUI views. So the first thing is let's do the font. So what's great is that when I click the period, Xcode intelligently autocomplete or basically presents some suggestions for me, and one of them is font. I could click enter and it basically autofills and basically selects the argument that I want. I want the font dot title value that I have here. Again, Swift can infer. So what I could do is I can drop the font thing in the front because it knows that this font view modifier expects a font. Okay, so I could just drop the first thing off. So now this title font has been applied to this text. All right. Now we also change the font weight to be bold, but I want semi-bold. All right. Now let's do the same thing to the player one and player two. So here, the thing I want is of systems. So you can see here how font, I can have some system presets. So I could do, for example, again, caption, footnote, headline. These are system fonts already baked into SwiftUI. But I could use a system, I could use a regular number, for example. So here I could use this dot system size view modifier. And I could basically pass in a number. So I could say I want a size of 20. So this is more fine-grained control of the font size that you want. And also I want the font weight to be, let's do semi-bold as well. Okay. So here we can see that applies to the first player one. Now I want the same thing for player two as well. So now you can see they're both with the same styles. Now you might be saying, hey, okay, these two, we have duplicate code, right? They're basically the same thing. So what's great is that I could basically delete these guys out of here and I can apply it to the container, the VStack. So when you apply it to something like a stack or HStack, a VStack or a ZStack, it applies the view modifiers to each of its subviews. So what we had earlier with the two view modifiers on each of the text, this is doing the exact same thing. So now you can see it, we have it right there as well. And now let's say I want to make player two to have this blue color. So Dylan showed a view modifier called foreground style. And I could basically pass in a style. And I want the style of color blue. All right. Now I can, again, Swift can infer, so I can just drop the color off of that. So I could say dot foreground style dot blue, just like that. So you can see we have it right there. Okay, so now we can see that we have a little bit of spacing here, right? Within player one and player two. So you could also customize a stack, and here I could write a parentheses. I could see these different arguments that I could pass in. One of them is spacing. So I could type spacing here, and I want a spacing of 10 points. So it's gonna, space those two out with 10 points between them. All right. So that kind of looks what what we're trying to do. Okay. So that is our kind of score header for now. So now let's take a look at how we could write the green background. Now, The way I like to do this is something called a Z stack. So you can think of this UI as a layer on top of this color background. If you ever used Photoshop before, you could think about layers as layers that lay on top of each other on the Z axis, right? The axis pointing to you and into the screen. So let's do that. So I could right click on HStack and I could scroll down to embed in ZStack. So I can click this button and Xcode puts the code, wraps it within a ZStack. Cool. So now I could um, add the color background. And what's really interesting and cool is that colors in SwiftUI are views themselves. So I could do color dot green, and you could see, boom, our score header view is now laid on top of our green background. Okay, so how does this work? So if you notice, these subviews, our subsequent subviews, are layered on top of each other, right? So if I add something here, like for example, a text, it will layer on top of our score view, and so forth. All right, so our green is looking a bit too zesty, a bit too vibrant. So let's turn down the opacity a little bit. So we use the opacity view modifier, and it takes a double, which is a decimal. Zero means it's totally transparent. One means it's totally opaque. So what I'm trying to do here is let's take, I think a zero point 0.2, a 20% opacity, I think looks good. So again, it doesn't look quite right because now we have these spaces, right, that you see on the top and bottom of the iPhone. These areas we call safe areas. And the safe areas are for reserved for operating system controls. For example, the notch on the iPhone, the bar, the this thing, this horizontal thing where you flick up to go back to home screen, right? So that's reserved for that space, but we have additional view modifier called ignores safe area that tells that view to ignore the safe area. So we want to expand out to the whole thing. All right, so that takes cares of our background. All right, let's take a look at how we could position our score view to the very top. All right, and also take a look at how we can implement this button. But as you notice, as we're building new features, our body is getting more and more and more complex, right? And I don't like that. I like to keep it simple, and when I just read the body, I could tell exactly what this view is. So what we could do is that we could bring or basically abstract this H stack or our score view into a variable. So what I'm gonna do is I can select this and I can hit Command X to cut, and then after the curly bracket of this body property, but before the last bracket of the view, I could basically create a variable. So I could do private var. I'm gonna call this header view. It's of type sum view. Again, this is just you have to do this. It's just how it is. And I could paste what I had cut earlier into here. So now what I could do is I could refer this header view right after, right within my Z stack. So I could do it just like this. So you can see with this quick refactoring, our body is slimmer and you can exactly see what it is, right? We have our background and we have our header view. Perfect. This private keyword means that this header view property is only accessible within this content view. Other views don't need to know about our header view. So we mark this header view private so that only things within our content view can access it. Cool. So now let's take a look at how we can implement a button. All right. So I'm going to go down here and I'm going to create a button. Again, I'm going to abstract this into a variable or property. And I'm going to call this take turn button. And it's of some view. Now we are going to create our button here. So before that, I'm just going to put, add it to our Z stack here. But I want our UI to be on the same layer, right? Again, what this does is that it takes our button and superimposes it on top of our header view. But we want header view and our button to be on the same layer. So what we do is that we could wrap these two in a Z stack. like so. Okay, so now they're on the same kind of layer. All right, let's take a look at how we could build our button. So we use the button view in SwiftUI, and it takes in a action, which is a function that actually runs when we click on the button, and the content or the label of what the button actually looks like. So this is a syntax I like to use. Again, here within these curly brackets is what gets run when I click the button, and here is actually the content of the button. All right, so I could see here that this button has these, again, two subviews I can identify. This icon on the left and this take turn label, right? So again, what this is telling me, I want an H stack. So I'll create an H stack like so. And then let's create our text first. This is simply take turn. And our text, I want it to be bold. I could just use the dot bold view modifier. And also I could use the font. So I'll select the title two fonts and I want to make it white. So I use the foreground style of dot white. And you can see here that our take turn now here is now white, right? Cool. So now let's take a look at how we could implement this image here. Now, if you notice, I didn't import an image here for that play button, right? So how in the world did I get this there? So Apple supplies a bunch of symbols for you to use, and they're called SF symbols. So I could go to this plus sign right here, and this is the library, and I could search for a symbol. So select symbols, this library right here, select that, and you can search up for a symbol. So the symbol I want to use is play.circle.fill. This one right here. I can right click on it, I think. Let's see. I could just basically copy this. And then this is actually an image. So I'll use the image view, and I could use the system name version of it. Basically, it takes in a string, and that string is our SF symbol name, which is play.circle.fill. So in our SwiftUI view, you can see there it is, our little tiny little button. All right. All right, let's style this button a bit further. So I want it not to be blue, but I want it to be kind of transparent. So what I could use is something called a material. So with this foreground style view modifier, it also accepts materials. And one of them is something called a regular material. And that's just one of the system defined materials that Apple provides for us. And it has a transparent kind of background or texture to it that you see a lot in Apple's native apps. All right, let's just bump up the size of this a bit more. I'll use a custom size. Again, that's .font.system.size of 35. And okay, let's see what we have so far. Okay, that looks quite good. Now, we want to add a background to this button to make it green. So on the H stack, I could use the background modifier, and then I could use the color of green, and that will apply a green background to that H stack, as you see here. Now, you can see that we also have some padding between the H stack and the button, or the outer border of the button itself. So what we could do to add some padding is I could use the padding modifier, like so. All right. So now you can see we have applied some padding. Now, it's very important that you make sure that your view modifiers are ordered in the right way. When I swap these two view modifiers, the behavior goes back to what we had originally. Why is this the case? Well, when we apply view modifiers, what we're doing is we're actually creating a new view. So this view modifier applies to this H stack, and that creates a new view in itself. So this is a new view. And then we're applying that padding to the new view. So what happens here is that our padding is actually being applied, but it's actually being applied outside of our H stack. And our background is being applied to the H stack, right? So let me see if I could double click this, and let's go to our element inspector. So you can see the bounds. There you go. When I double click on the padding view modifier, you can see the bounds of the padding, right? We're applying the padding outside of the background. So it's important that you make sure that you order your view modifiers correctly so that we're applying our background onto the padding as well. Cool. So, all right. So let's take a look at how we can make our corners a bit more rounded. I think Apple, a lot of apps are pushing for this more rounded kind of UI, and we could do this via something called the clip shape view modifier. This clip shape takes in a shape that we basically, it basically takes the shape and it's like a cookie cutter basically. It basically uses that shape and just stamps on top of your view. And what we want is a rounded rectangle with a corner radius of 20. So what I'm doing is that I have this round rectangle with a corner radius of 20, and I am basically taking that as a cookie cutter, and I'm going bam, and I'm just basically cutting it out. So that's what it's doing right there. Now, as you can see, we have some spacing to the left and right of take turn. And so what we want to do here is we use a spacer. So again, a spacer takes the available space on the left and right hand side and allocates to those spacers. I want two spacers, one before take turn and one after take turn. What this does is that it takes the available space to the left and right and splits it evenly to the first spacer and the second spacer. So now when we look back to a simulator, you can see it expands out. Now, I want to be more specific. I don't want it to take up all available space. I want to be more specific of the width of what I'm dealing with. So here, I will be adding another view modifier called frame. So I'll basically add this frame, and a frame has, again, it has a width and height, but one of its versions only takes in a width. So I want a width of 300 to be exact. So here we could see, oops, here, if we go back to our canvas, we could see that we're specifying our button to be of width 300 points. And there we go. All right, so now let's take a look at how we can position the score view and our button at the right kind of positions. So again, I want the take turn button to be the very bottom. I want the score header to be the very top. Again, what this is telling me is I want a spacer. So I'll put a spacer between the header view and the take turn button. Let's go back to our canvas and you can see that it pushes, again, takes all the available space, allocates to that spacer, and now pushes everything to the top and bottom. I see my score header is touching the edges of our screen. I don't want that. So I'll wrap our VStack with a padding. So I'll basically, on our VStack, I'll add a padding. And again, this adds some default padding that SwiftUI calculates and it applies it on there. If you want to be more fine-grained control, you can also specify a padding with a explicit number of points. So in this case, it applies a padding of 100 points to all edges. Again, there's different variants where you also can specify the edge set. So you can specify, I want a padding, for example, to the very top of 10 points to the top. So it applies 10 to the top only. But in this case, we want padding to all edges of our VStack. Very cool. Nice. So now let's take a look at how we could implement our dice view. So what I'm talking about here is this dice thing that we have right here, okay? And first off, we need to represent a dice in code. What makes a dice, in code? So let's do this. So I'm gonna create a new file. So what I'm gonna do is on Hogstarter, I'm gonna right click, I'm gonna select new file from template. Again, there's a lot of different files here. The main files you're only going to be working with is Swift and SwiftUI, right? Those are the two files that we want to do. In this case, we're writing some logic or basically representing our data model. We're going to use a Swift file. We're going to click next, and then we're going to save this as dice.swift. And we're going to click create. So that creates our dice file. And again, it's just bare bones. We're going to keep this import statement. An import foundation is basically the library for fundamental Swift functions and abilities. But we're going to declare a enum, right? So we're going to basically represent, or how do we represent the values on each dice, right? So a dice has 7 different values or different cases, right? What are the 7 different cases? 1, 2, 3, 4, 5, 6, and this question dice. So I can represent this as an enum. As Dylan mentioned earlier, we use enums to basically encapsulate a discrete set of values and group them together. So here we can create a enum, which I'm gonna call dice value. All right. And within this enum, I can create different cases. So I'm going to do case one, case two, case three, case four, case five, case six, and case question. All right. Cool. So now I want to also somehow uh get the number associated to these cases when I'm adding the point system, when I'm calculating the number of points, right? So to do this, I could use something called a computed property. Again, this is something special to Swift. A computed property is a property that computes its property on the fly, or it basically has dependencies to basically any other properties within this enum or struct or class. So we're going to create a variable called numerical value, and this again it's a variable, it's a property, and its type is integer. So what I want to do is that I want to switch on the type of the dice value. Okay, so again, I have a dice value that I will create later on, and I will be switching on that dice value. So what I could do is that I could do switch self. So I'm switching on that dice value. So self is representing like that dice value that I'll create later. I'll show you later on. And as you see, that it says switch must be exhaustive. I have to basically enumerate all of the different cases. So I'll to do this, I'll do case dot one, case dot two, case dot three, case dot four, case dot five, case dot six, and then case dot question. And then after each case, I'll basically return that numerical number associated to that case. So here I'll do return one, return two, and then return three, return four, return five, and then return six. Now, when it's never going to happen, but for this question case, we're going to return zero if that happens, but that's not going to happen, right? So what this does is that when we get the numeric, when we call the numeric, or we basically do like dice value dot numerical value, it computes the value on the fly. So it's going to take itself, see what case it is itself. It's again, it's a very introspective kind of logic here. Like I'm looking upon myself. Am I one? Nope. And am I two? If I'm two, I'll return the value of two. Okay, that's what it does. Right. I also want to associate a string to each one of these cases, and I'll explain why in just a minute. I think this is a very clever way of doing so. So, what I could do is that I could basically assign a string to each of the cases, and I could basically use the syntax colon string. And what this allows me to do is that I could basically assign each of the cases to a string. And again, these are numbers. Okay, these are number values, but these are strings, okay? So string five, string six, and string question. Cool. All right, so that is how I'll be representing a dice value in my game. Now let's actually represent the actual dice itself. So a dice, I'll be representing a dice via a struct. Again, a struct is basically an encapsulation of a representation of an abstract object, a real life object, with properties, attributes. Properties are attributes. They're, people use them interchangeably, and functions. And we call them methods because methods are basically functions within a struct, class, and so forth. Okay, but they're basically functions. So I'm gonna represent this dice via struct, and I also want to make it okay. So what makes a dice a dice? Okay, it needs to have a value. So I'll create a property called value, and its type is dice value. Okay, next let's create and also in SwiftUI, when we're basically iterating something via a list or something, or again, we'll use something called a lazy, I think it's a lazy VStack. But when you're basically looping through like structs or your objects when SwiftUI, each object or each instance needs to be identifiable. So SwiftUI needs to identify each of the items that you're looping through so that it applies animations automatically. So it knows, which things to apply the appropriate animations. So what we could do is that we can make dice conform to the identifiable protocol. And what this requires us to do is to have an ID property. So I'll create another property called ID, and we're going to assign this to something called, with a UID. A UID is simply basically a random identifier. It's just a random number of bits. Okay, don't worry about it. It's just like a random. You can think of this as like a random thing. All right. Um, cool. Now, I will also want to reference the image via a dice. Okay, so what this means is that when I create my dices and I want to display them, right, as an image, I need to get the asset name, right? I need to refer to these assets that we have right here. So how do we do so, right? Well, if you notice, right, all of the names of these dices, they go from dice underscore one, dice underscore two, yada yada yada, all the way into dice underscore question. So looking back, you could see why I have this in place. So on our dice, we could actually create another computed property. I'll call this image name. Its type is a string, and this is the image name that I'll use, pass into the SwiftUI image view to actually render a dice on the screen. I need to somehow get, these strings for each dice. So how do I do this? All right, what I could do is that I can return and use string interpolation. Okay, again, I want to somehow do this when the dice is one, do this when the dice is two. So we have this one piece of information right here. We have this value, right? We could use that and plug it in right there. So I could use string interpolation and I could plug value in there. And now I want the string value assigned to each case. What this actual assigned value is that each enum has a property called raw value, the corresponding value of the raw type. And that is this string. So if this dice I create has a value of one, of case one, what this image name is going to do is that it's going to compute on the fly this string where I'm getting this, you know, one string and I'm basically inserting it to right there. So it's dice underscore one. And then if it's a question dice, it's going to replace that with this question string. All right. Again, this is a bit trippy, but this is going to work really well when we create our UI. Cool. Let's create our dices view, like I mentioned before. Again, our dices view is this view that displays our dices. So I'm going to create a new folder here, file, and this is going to be a SwiftUI view. So I'll select SwiftUI view, click enter, and this is called dices view. I like to name my SwiftUI views with a view at the very end. All right, that's how I'll name. So content view, you can see content view is a SwiftUI view, dices view is a SwiftUI view. Very clear. Cool. So we have now our preview, we have our dices view right here. Okay, how do we create this grid looking layout? So what we want to do is that a struct, again, it can have properties, right? What we want to do is we're going to pass dices into our dices view. So we're going to create a property called dices, which takes in an array of dice. Cool. So now we could use dices within our body here. Now, as you can see our previews, it's going to yell at us because it says we're missing argument for dices because we added this property for dices. We need to pass something in, right? So here we could just basically pass in it and let's create some dices for us in the get-go. You can create dices. You don't need to create this many dices for the moment, but you can just create like one or two. That's totally fine. Cool. So we have our dices now. Let's create our grid. We're going to use something called a lazy V grid. So this is a grid that, again, it display things on a grid with columns. So we have to specify what our columns going to look like. So I want 5 columns, no matter what. So we're going to create a property here called columns, and then this is going to be an array of something called, grid items, right? So what we're going to do is that we're going to have a grid item, and we're going to give it a fixed size of 70 points. So what this is telling me, what this does is that it's saying that, again, I'll pass this columns array to lazy vgrid. And so I'll copy this 5 times. So 1, 2, 3, 4, 5 times. And then we're telling that each column will be 70 points wide. All right. So here in a lazy vgrid, it takes in columns. I'll pass in that columns property there. I want to give each of the items within our grid a spacing of 20 points away from each other. All right, so we have our grid here. Now we need to actually loop through our dices to display our dices onto the screen, or basically into the grid. So we can use something called a for each. A for each basically loops through a collection and basically creates views for them. Okay, so you could specify a particular view for each item in that collection. So we're going to loop through for each item in our dices. We can capture or get each of the items, each dice via this syntax. Again, it's a bit weird, but I'll explain right in just a moment. So here we have this dice and we have this in. What this means is that this dice is sort of like our for loop, our variable in our for loop. Remember how we did for I in 0 dot dot, so forth? That I is like our dice. So as for each goes through our dices, we're getting each dice back via this variable that we declared here. Again, this could be anything. You can name this whatever you want. Here is a required keyword called in, and this basically kind of separates the parameter up. It basically separates the things that we get back as it's looping through with the actual view itself. All right. So what does our view look like, right? We want to display an image. So we're going to do image, and we're not going to do system name this time because system name is reserved for SF symbols. What we want is use the images in our assets folder. So we're going to use, we're just basically passing a string into image. So dice dot, now conveniently we did image name, right? Boom, there we go. Look at that. You see how we have our dices on the screen. Isn't this cool? All right, so we're gonna bump up the size a little bit. So these images, right, they could be resized. So to resize an image, we can use the resizable view modifier, and this allows us to resize the image. Again, those looks, so it basically, does some stuff where you can make it resizable. But what we want to do is that we want to make sure that the aspect ratio of the image is of a certain aspect ratio. Okay, so we're gonna use the aspect ratio content mode, and you could do fit or fill. We're gonna use the fit aspect ratio. So we want to keep the aspect ratio of the image just like how we had it before, right? Cool. Again, these are looking a bit chunky. We're gonna kind of make it a bit smaller so we can use the frame again, frame view modifier with a specified width of 50. And I'm also do the height as well. So I'll make this a square. So each one of these images is 50 points high, 50 points long. So here we have our dice view. All right. And what's really cool is that we can pass dices into here, right, on the fly, and SwiftUI will re-render the view to update the dices that we see here. Okay, so again, this is going to be really cool in a moment. So this is all we have. This is all we do for the dices. And just to reiterate again, this is not the actual app itself. The app is not this. What you see here in the canvas is powered by the preview. So I could basically delete everything and leave one dice left. And you can see, I can see it right here, right? So this is just for you to prototype, to build apps, or to build your views without having to rerun your app every single time. And I'll show you how to rerun your app in a minute, but we'll do that later on. Okay, so here we have our dices view. Now let's take a look at how we could create this sheet thing that we have right here. So let's go back to our content view and let's see what we have back so far. Okay, so you could see here we're gonna need a dices view to display our dices on the screen right here. And I don't know, for those who came a bit late, when we don't have dices or the very first time or very when we first launched the app, you see a pig in the right in front of you. All right. Um, so we're gonna implement that right now. So first we're going to um um basically, okay, so here we're gonna add another spacer, and then again, here we're gonna add our dices view, and we're gonna have our dices again. It takes some dices. I think for now, again, we'll just create a dice just to put in there, just to populate that, and there you go. You can see it's on the screen now. Um, cool. So let's actually now create a I'll create a variable just to hold our dices here in minutes for now. Again, this is going to be all dynamically driven by uh our manager that Dylan will take on. Will explain how we'll create our game manager to manage game state later on. But here and now, where we can replace our dices array with our property or variable dices, just like that. Now, when there are no dices on the board, we want to display a pig. So to do this, we basically can use an if statement. So if dices and a collection, so an array is a collection, a dictionary is a collection, and a set is a collection, has something called is empty. So I basically check if dices is empty, we want to show a pig. So we show a pig via emojis. What's cool is that you could have text as you could put emojis as strings in Swift and display them. All right. So if the dices are empty, we display our beautiful pig. And if it's not, we display our dices view. So we can use an if else statement just like that. Now, our pig, to make our pig actually show on screen, we'll basically delete everything here. So we have no dices on the screen. Um, and it's complaining because it doesn't know the type. It's like, okay, empty array, but what are the stuff in that array? It doesn't know, right? Swift is smart enough, but in this case, it doesn't know everything, all right? It's like us. We're kind of we know something, we don't know other things. So we could help Swift out by saying what elements are supported by this array. So to do this, we could basically use this syntax. And what again, this is sort of like the data type, where we're saying that each element within this array is of type dice. I could also do a different way where I could basically, instead of this syntax, I could do something like this. Um, um, we'll just hold off for now. Like so we could do something like this, I believe. So wait. Um, Give me one second. I think I'm having a brain for a moment, but we'll just keep it like this for a moment. Was it like dice? Oh, it was like this. Yeah. Okay. Sorry. Sorry. I just had a brain for a moment. The other way to declare an empty array is using this syntax, where we use this. Okay, it's this syntax. It's the same thing. We're declaring an empty array. So whatever you fancy, you could choose whatever you want to do. Cool. So there we go. We see our pig. We're gonna make our pig a bit bigger. So we're gonna use a system size of 100. Okay. Okay, looks a bit more, high quality pig. Um, Oh wow, that's a lot of shadows on the pig. Anyways, so that's our pig right there. And if we have our dice, if you have a dice here, we will now, show the other condition, like so. So now dice is not empty. We switch to our dice's view. Again, it's looking a bit cluttered here, so I can abstract this away, and let's put it in a variable. I'll be calling this our dice's view and then paste it in there right there. Now it's going to error at us. Um, let's see what is going on here. Okay, so I'll put this dice's view right there. Okay, so what the issue here is that we can't put an if statement within a property like this. Okay, what we can circumvent this is adding this view builder kind of declaration on our variable to make this work. So if you ever find yourself needing and having an if statement within this, like, your property here, you could make it work by adding this at view builder. Again, I'm not going to explain what this does, but this is how you could circumvent this. Okay. So there we go. Our home screen has been now completed. The next step is to create our sheet right here. All right. So to create a sheet, I could use something called the sheet view modifier. So I'll on the Z stack, I can use dot sheet, and this is one of the ways that we could present some navigation in SwiftUI. So here it expects a property called is presented. Okay. So what's really, again, this is a bit weird, but it wants us to supply a variable in there so that if it's true, we'll present the sheet. If it's false, we'll dismiss the sheet. All right. Now, to have properties that change in your SwiftUI views, again, this is very important. You need to use something called an add state property wrapper. So Xcode right here intelligently knows that I'm trying to present a sheet. So you can see it, it kind of like suggests this kind of thing here. So I'll click tab here. I'll rename this to say is showing config turn sheet. I like to name my variables a bit longer and more detailed because I don't know. I think that makes it more clear for me. So again, this will change, right? So in the beginning it's gonna be false, but when we click on the take turn button, well, it's gonna be now be true, right? And then when we dismiss the sheet, it's gonna be false. So the issue here is that changing properties in a SwiftUI struct is not allowed, all right? Due to inherent properties of a struct. You can research this on your own time. It has to deal with value types versus reference types. Um, but to circumvent navigate this is that we can use this add state property wrapper around this variable to basically tell SwiftUI to manage the actual storing of the data. So SwiftUI is going to manage the storing of data for us. Okay, it's going to take this value, and SwiftUI is going to manage for us. When the value of that data changes, if there are any dependencies within our view body, so if I'm using is showing config turn sheet in our code or in the body, SwiftUI will intelligently re-render our view. Okay, because our view depends on this variable. Okay, so again, SwiftUI manages the data stuff for this variable for us. If it detects it changes, it will re-render our view if there are dependencies using this variable. All right. So in here, we're going to do something called a dollar sign is showing Turing. For is presented, you need to use dollar sign is showing config turn sheet. What this is that this is called a binding. Okay. What this means is that internally, Apple has coded this so that it takes in is showing config turn sheet, right? When we dismiss it, right, it will change it to false, right? So what this does is that internally, what Apple's code is going to set it to be false, and it probably, sometimes it sets it back to be true, but it's going to write it back to this variable right here. So this is what we call a source of truth. So the actual data is stored here, but we're passing sort of like a reference into this sheet view modifier. And whenever we dismiss the sheet, Apple's code will change this variable to be true or false appropriately. And this basically gives this sheet view modifier not only read access to this variable, but also write access. So within, again, Apple's own code, it's able to change this variable appropriately. All right. Okay. So we want to change is showing config turn sheet. So within our action uh, part here, we're going to basically toggle it. So we're going to do is showing config turn sheet, and we're going to toggle. So what this toggle does is that if is showing config turn sheet is false, it will change it to true. If it's true, it will basically change it to false. Okay, so that's what the dot toggle method does. Okay, so now here, within here is actually where we actually present our sheet view, our configure turn view right here. I know we're out of time, but we still have a lot going on still. So if you have time, we greatly appreciate if you could, continue. If not, there's going to be recording later on. But we're going to keep on going. All right. So here's where we basically, again, present the sheet of what the sheet actually looks like. So here I could say, hello world. All right. So now let's click. Okay. Make sure you have this, the leftmost side option selected. This is the live view. Right. If you have this selected, you're not going to be able to click anything because this is the element kind of inspector. You're able to expect bounds of views. So make sure you have this selected. Cool. So let's click on take turn now. And voila. So you can see it kind of presents the sheet. Again, why is this happening? Well, when I click the take turn, when I click on the button, it calls this. It was false before. Now it changes to true. Um, the sheet view modifier, right, we pass in is showing config turn sheet into here, and it changes to true. And again, Apple's code detects that and presents the sheet with our view, our sheet view right here. I could also drag this. I could dismiss it. So when I dismiss it, again, Apple's own code changes this to false now. What this binding allows us to do is that, again, Apple's own code is able to change the value here, right? So that's how we could build our sheet. I'm going to create a new file. So sorry, guys. I don't know what's going on, but I'm still here. So let's continue onwards. Um, Cool. All right. So let's start. We're going to create a new file called uh, turn config view. Again, make sure, hopefully you're able to see what I'm seeing. If you can't, please just yell at me. All right. I recognize I'm not sharing my whole screen. So there we are. Cool. Hopefully everyone can see the screen now. Yes. Okay. Very good. All right. So let's create our turn config view right here. All right. So what we're gonna do is that we're gonna create the picker item that we have right here. So this is something called a picker. So we're
Wait, Josh, I
gonna
think your screen's still off.
it's still off. Okay. Uh
Oh, he's back. Oh,
There you go.
am I back? Sorry guys, am I back? Okay.
Yeah, yeah.
Okay.
yes, you're back. You're back.
Okay, good. All right, so we're gonna create our picker. So our picker here, we're gonna use our picker view, and this picker has a title. So we're going to create our title here. Um, and okay, so we're gonna call this number of dices, and it has a selection as well. So when we're selecting our picker or item on the picker, uh, what happens is that we can assign a value to store that selection to. Okay, and again, this needs to be a at state variable because this variable changes. So we're going to use a at state private var num of dices, and we're going to initialize it to a value of 1. All right. Again, when we select on the picker, Apple's own code is going to take what we pass in and mutate it. So we need to use a binding. So $sign num of dices, like so. All right. So now we have to populate our picker, right? So our picker, we're going to use a for each, similar to how we did our lazy v grid. So v for each, and we're going to enumerate over some collection. What we're going to do is that we're going to enumerate from values of 1 to 10. And we could use the closed range operator, open range operator right here to loop from 1 to 10. And then here in the, I can get each value back, be here using this syntax, dice num in, and after the in is actually the what we want to show on screen. And that's going to be the text, right? So um, dice num, I believe, is a number, so I can use string interpolation to convert it into a string. Cool. So how does picker know um what value, right? What value to actually put into num of dices, right? So there's this view modifier called a tag. So we're basically tagging each text with a value so that when we select on an item in the picker, it takes the item in the tag and assigns it to whatever you put in your selection. All right. So what we're going to do is that we're going to tag each thing with the integer, the number, right? Dice number is an integer. So when I select on this picker, I select 7. It takes the tag of that number 7 text row and puts it into, or basically assigns it to num of dices. That's how it works, right? There's our picker. Now, I want to show this text to the left. I think this text is for like accessibility purposes. So, for those who don't know, Apple has this feature called VoiceOver. And VoiceOver is for people who have disability needs, and you can enable in settings. And so, people who have disability purposes can navigate your iPhone or whatever your Apple device by swiping or tapping on. It's going to like select items on the screen, and then you can like swipe left and it can select the next app. And so it can also read out things to the user. And so this text here is, I think, for like accessibility purposes. But if you want to show this number of dices, we need to wrap it around in HStack. All right. And this HStack here, we're going to have our text num our of dices, and this is going to be bolded. And we're going to put our picker in our HStack as a subview. So here we can see that now they're aligned horizontally. Perfect. Now I want to align it to the left. So what I can do is I can use a spacer after the picker to take all the available space, put it to the right. Excuse me. Cool. So now let's kind of encapsulate this. Again, it's getting a bit messy here, so it's a good thing to kind of refactor, put it in its own property. I'm gonna call this dice picker, sum view, boom. All right, dice picker. Let's put it in our view body. Nice. All right, so now let's take a look at our, okay, now we're missing our dices view. So we're gonna do a V stack. All right, put our dice picker on top. We're gonna put our dices view and our dices there. Um, Now our dices are going to be, created, um, depending on the number of dices that I have, right? Um, and how this works is that, okay, right now I'm going to initialize this to this empty array for now. What I want to do is that on change, when num of dices changes, I want to perform an action. What is that action I want to perform? I want to generate those question mark dices that we have on screen, right? I select the picker, I select the item, a row in the picker, num of dices become 9. And upon that changing, I want to execute some code or some logic. Conveniently, SwiftUI has this thing called on change, this view modifier. On change of num of dices, what do we want to do? We want to um, execute some code here. And one of it has an old value and it has a new value. It gives us back. We don't need the old value. We could just use the new value, right? So in here, when num of dices changes, I can get the new value of the dice back here. Okay. So what I want to do here is that I want to basically create a list of an array of dices. So what I can do is I can create another state variable called dices. And again, I can initialize this to a, excuse me, empty array of dices here. I can pass that into here. Actually, I'll call this question dices just to be more specific of what I'm working with. All right. So what I want to do is I want to loop through the number of dices I have. So for I in 0 to new value minus 1. So again, this basically loops through number of dices times. So if num of dices is 9, I don't think it can be 9. If num of dices can be 6, it will go through this 6 times. All right? Because again, this is exclusive. So I start at 0. So 0, 1, 2, 3, 4, 5. All right, cool. So in here, I want to create a new dice. So I can create a new dice via dice value, and the value I want to be is of type enum question, of case question, right? And what I want to do is I want to append to my question dices, uh, like so. Um, so like that.
Because I think you're muted too.
Sorry, thank you. So when I click on number of dices here, you can see it creates 9 dices, as we see here. So let's click 10. It does not do 10. Why is that? Because we're every single time number of dices changes, we're actually adding new dices to what we did earlier. So what we need to do before is that we need to delete everything. So we can use the remove all method to remove all the devices every single time num of the dices change. So when I click seven, it clears everything, creates the dices. When I click 10, clears everything, creates the dices. So that's how we were able to do this logic. Nice. So let's take a look at how we can do this toolbar thing. So in iOS terminology, the top navigation bar here thing is called the toolbar. And in toolbar, we can actually place buttons and actions that we want to do. So to make this work, we need to wrap everything in a navigation view. So um, what you normally want to do is probably, again, there's also a navigation stack where you could basically push pop things. I think also a navigation stack also should work. Um, Navigation view was the older API or the older version of navigation stack, but they work, in this case, they work interchangeability. All right, so now on the VStack right here, we're going to add a property called navigation title. And that is going to be the title that we're going to put on uh, the navigation header. And this is the default style. It's going to be big letters, right? But there's also a view modifier that specifies the display mode of the title, and we used inline. And what that does is that it's going to inline our title at the very top, just like so. Okay, we're gonna add some padding before everything, just to make sure that everyone's, not touching the sidebars, right? So the edge of the screen. Right, how do we create our buttons here? We have a dismiss button, we have a done button. We use the toolbar view modifier, and within here we could create toolbar items. So we're gonna create our first toolbar item representing the close button, and we're gonna place it to the top bar leading. Um, so the top bar leading is actually the left of the topmost bar. Um, the reason for this is because Apple, right? Apple supports many languages, right? Some languages, for example, like Arabic and Hebrew, goes from right to left instead of left to right. Right? English is a right left to right language. So depending on the language setting of the user, leading corresponds to the kind of start of the language. So for example, if the user selects Hebrew or Arabic, leading is the right instead of the left. All right, so that's the terminology here. All right, so we're going to create a button here, and we're going to basically create an image, and this is going to be of system name, and this is going to be xmark.circle.fill. Again, this is as a symbol that you can look up. I'm going to create the size of a size 25 points. I'm going to make this of gray color. All right, so that's our toolbar item to dismiss our sheet. To create the done button, I'll do the very same, but now instead of toolbar leading, I do toolbar trailing, a top bar trailing. All right, and then instead of this uh, image, I'll do a text called done. I'll style this to be bold, like so. How do we now? Okay, so when I want to dismiss a this sheet from this this X mark, nothing's hooked up right now, right? So if I go to content view, and what's really cool is that with canvases for previews, you could pin previews. So I can click this pin icon and I can pin it. So then when I go to a different view, it's still there, right? And I could if I want to see the turn config view powered by this preview, I can click this one right there. But this pin one is very convenient, so I could just stay here. All right. Um, so I could now click on this. Oh, okay. I need to add turn config view to our sheet that we want to present. So I click on this. Nice. I click 10. There we go. But when I click on this X button, this close button, nothing works. So how do we dismiss our sheet programmatically? So we can do this via the environment. Every view in SwiftUI, every SwiftUI view has environment. And an environment for a view is basically a bunch of properties, a bunch of system abilities that you could do that subviews. So every subview inherits from its parent view. If you take a look, Dice's view is a subview of turn config view. So Dice's view's environment, you know, inherits its environment from turn config view, right? I could do some powerful things as well. To get access to abilities in the environment, we use the add environments property wrapper, and we could use a key path. So here's like what we want to select in the environment. Turns out there's a dismiss action in the environment that we could get, and this is a function that we can call. So in the top bar leading right here in our X mark, in our close button, we could use just call this dismiss function that we have from the environment, like so. So we also can dismiss it in our done button once we're finished. So I could click on take turn, and there we go. We can click on X to dismiss it, and we click on done to also dismiss it as well. So yeah, that is sort of the main UI for now. Um, again, I know this is really over time. I'm really sorry, but this will give you a lot of tools and things necessary for you to actually create a iOS app from scratch. Um, and we think this is a good tutorial to kind of give you a bird's eye view of everything. But for now, I'll turn it over to Dylan to implement the game manager. Dylan, do you want to share a screen or do you want to use mine?
I think just for safety, I will yeah, I would just use mine. So let me set up on my side real quick.
Again, I'm really sorry we're going over time, but iOS development is there's a lot going on as development. It's not an easy thing to get into. So but yeah, but thank you for sticking this evening.
All right. Give me 1 second. Sure. All right. So yeah, if we kind of look at through our UI right now, right? A lot of things are just static. So let's just kind of pull out or let me remove some things that shouldn't be here. Or give me 1 more second. Um, All right, so yeah, I switched to a different branch that only has the UI, right? So right now we kind of looking through our UI. A lot of things we have are just static, right? There's no real change. So for example, dice view right here, right? These are just a like arbitrary number of dice, right? There's no real difference. I think same thing with our, goal, player, our foreground, right? Everything right now, the way we have it set up, is simply just, you know, static. It's all the same. So we need to kind of add some logic to our game. Go right here and hit new file. All right, let's create a new file called game manager, right? And the kind of the whole purpose is we want to be able to kind of create some logic for our for our game to in order to allow us to actually change things. Such as in our original game, we have, rolling the dice, calculating the score, and even like, I think you kind of saw earlier that every time you picked a different player, right, kind of on like right screen right here, there'll be, the foreground be changing. So let's let's go into our game manager, right? I think one thing, right out of the gate that we can easily implement is, and let me just add a couple of APIs. And I'll explain what these do later, right? One thing that we can go out of the gate is create a sort of class called player, right? So we can create a player class, right? And what our player class will store is maybe some variables such as like their color, right? So let's say we want one player to be, we can have both be blue, we can have one be red, one be blue. So let's just say for now, both are blue. Like, let's just make it both are blue, right? So we have our player and var points, right? We want to be able to calculate how many players have what the points. So right here, right? When you're doing a class, right? These are our class variables. What you want is you get to, put the types. So right here, these are the variables and the variable types. And then right here, like not, you don't have to do it, but because we kind of need it. This is how you would initiate a class, right? So if you have kind of more questions on how like this works, a lot of times the way this works is, well, sorry, not the okay, like the best way the what I was trying to say is like if you're kind of curious more about like this sort of like formatting of like programming or like how programming works, there's a depending on what college you go to, there's always a class called like data structures and algorithms that you always teach you about object-oriented programming, where you make a lot of classes and methods for the classes. So this is what our game manager is going to follow heavily on that. So right here, right? And then so creating our initializer, right? So every time you make a player object, you create like or sorry, every time you have a player like class, right? You make an instance of it. So on each instance of our player, we would have this sort of initializer that sets everything up. So you kind of see later why those come in play. And going back to like functions right here, right? We had to kind of set the parameters, right? So the parameters right here, we have color and then points, and by default we want everyone to have 0 points from the get-go. Okay. And then I think something that would just help us later is adding a enum, right? So because right now in our game we only have two sort of cases, right? Either our player is going to be player one or player two. Let's just create a sort of enum where we have a case where it's one, and then another case where it's two, right? So it's either going to be player one turn or player's two turn. You can kind of see where this is helping out later. All right, cool. Now let's add in class game manager, right? And create a variable. So what's something we need, right? We only have two players. So let's make a variable for player one, right? And right here, this is us creating an instance of a player, right? So the player class is sort of the blueprint, right, of what each sort of like thing looks like. They're kind of going deeper into like what programming is for people who don't know it. Like the main idea is like kind of think of like, hey, you have a person should have arms and legs and some sort of like hair color, but not everyone needs to have the same, right? And so you can kind of think of like there's a human class, but then an instance would be me, like I am an instance of the human class. So let's go right here, give this color sorry, give this player the color blue, and then give player two the color blue too. Okay, cool. So we have our two players. Now, let's sort of like what do we need, right? So if we kind of look at turn config, right? Turn config is like, the idea is we go inside, we pick a number of dice, and then we roll the dice, right? And kind of seeing right here, we already have a sort of dice struct. And also like additionally, we have kind of like a layout right here, right? So each dice will be put into an array. In turn config, each dice will kind of like so they like essentially the way the dice is made is it has an instance of a dice which each has a number in it. So we can kind of create an array right here that stores our dice similar to the way we have it. And there's different ways to kind of create like empty arrays. You can do this equal method and go like this. I think another way, though I don't typically do it, is you could do dice and then some little empty parentheses right here. So there's one way to do it. So let's create an empty array to hold our dice. And the reason why is we want to be able to save the dice, be able to put it into our main kind of like content view. Because you kind of see a layer that like in our dice view right here, all the dice are laid out. So we want kind of like a shared information on how many dice is on the board. So like, the dice that get presented in turn config, we want to be able to kind of like see that get reflected into content view. So having this dice array is nice. And then let's do current player turn, right? So in like a class, right? We can also kind of create like as you kind of see right here, you could in theory just make it empty, right? Hey, like this will be this will be like a type that has nothing in it right now, or you can just say straight from the get-go, like, hey, we're gonna start with player one, like player number equals one. So right now this is our class variable. And then is game over. Something, for later. This would be added if we have like a winning screen and like a winner, right? These are sort of just like extra variables that we can have. And just right here, right, this little question mark, if you're a little curious, right? The question mark just indicates that the variable is an optional, and essentially what optional means is that it can either be, it can either be nil or something. Don't worry about that right now. We're definitely not going to touch on that because there's a lot of what optionals comes with like sort of like programming and like programming like heuristics that you have to do to like consider it, right? If you worked with Python or Java, right, this is the null or none. So right here, because like in theory, there is a chance that there is no winner, so it is a nil type. And right here we have our sort of let statement, right? And then just to kind of show you, right? Let's initialize our let variable. Let equals in 100. Let's say right here, now if I do goal score and try to put the 0, you kind of get right here a little like error. So right here, the reason why we use let, we don't want to mutate, right? So we always want our 100 points to be sort of like the threshold you need to win the game. So that's why we kind of have let. Once again, VAR means they can change, right? We don't want, you don't want the game to only be played with player number one. Like we want to be able to switch between two and one, two and one. But for now, we want the score to always be 100, so we use let. Okay, and then going back, we can make a sort of getter method, right? So going back to our switch statements, right? Right. If we do this, this allows us to kind of go get the current method. So, sorry, go get our current player. We do our switch case one, return player one, which is our variable, and then case two. So the one thing about having classes, which is really nice, is that all the sort of methods in the class, and you will see that we'll be able to take advantage of that later. All the methods in the class are actually able to interact with the variables, right? So you kind of see right here, we didn't have to do anything like put anything into this var, or when we make our functions later, we don't have to put anything into those functions to actually get, this information. It can simply just be called upon and we'll get it right away. And then let me fix this. So it's gonna be a little complaints about redeclaring and then current player. Turn. All right. So now we just gotta create our init method, right? An init works similar to a function. You don't necessarily need to have anything be put in, and we want to create a function to sort of reset the game. So let's just do a quick function. Right now, it would take nothing and return nothing. And as you can see right here, right, in our init method, we would do game reset. This was very important. After get after 100, there's a button probably that we will implement that says, "Hey, we're gonna reset our game." So I'm simply just adding a reset to everything, right? And this is all just actually look about it. This is all just copies of this right here. So I don't know. I just had it real quick. Equals false. Boom. And dice dot remove all. Okay. And if you're kind of curious on like where we're getting this dot remove all, right? Because this is going back, dice right here is an array. This is simply just a function that we have from the arrays, right? Um, these are just simply the functions that we have from the arrays. If you're always kind of curious on like how we're getting these functions, right here, right? If you just type in Apple developer, for example, array, right? You can kind of see that they have a bunch of documentation that explains what like an array is, how to use it, how they work, right? And you go all the way down, you can find some things, right? So this kind of goes back to like object-oriented programming classes and whatnot. The array has all these like inherent like functions, properties that you can use and access. And learning about these just comes with time. So the more practice you do and the kind of the more you code, right, the more you know about all these sort of things, right? So like right here, I think remove all, right? And then this is how the remove all works. And then there's the remove all with keeping capacity. There's remove. You can get like a specific instance. So, oh no, sorry. The remove is like you have to put where the index is. So, like coming to know like all these things, like for example, like few modifiers, functions, or even like types like int might have something too that we can mess around with. Like it all just comes with learning and getting practice with language. Cool. Okay. So right here, we can just do reset game. And yeah, that's perfect. All right, now we can do the rolling, right? So let's actually implement the rolling of the dice. So let's say roll dice. Right here, we have our, parameter, right? This is right now is the argument label and the parameter name. I think, oh, sorry. Parameter label, argument name, kind of get them confused sometimes. But right here is kind of just making a function, right? So we just type in func, what the function's name, and then what we need to put in. And additionally, too, if I really want, I can omit it. So now there's nothing, but within our function, we can still get reference to the amount. So in theory, I can just type in return amount. Gonna get an error because this should not return anything. It is a void function. But the idea is like you want to be able to make Swift readable. So, every time you're kind of doing all these name conventions and all these sort of like functions, variables, you want to make sure that it reads and like you don't have to look at a lot of documentation, right? The idea of Swift or the practice of it is you really don't want to like do a lot of comments, explain what each thing does. You want to be able to just kind of look at the code and know what the code is doing, just based on kind of the read. So let's remove all the dice, right? Because what we don't want is we don't want to count the previous roll, right? Let's say it's players like one's turn, he rolls seven dice. We don't want those same seven dice to be in players to count. And then right here, right, going back to saying about the omission, right? If you do the underscore, you're basically saying that you are like omitting. And then we're making a for loop. So going back, we're gonna make a close for loop because there's a like zero indexing Python, sorry, Python and like coding in general. And so we don't want to count the amount. So let's say our amount was 6, right? We technically start at 0. So 0, 1, 2, 3, 4, 5, 6. It actually runs 7 times. And because we're not using the actual number, right? We're not using 1, 2, 3, 4, 5 all the way to the amount number. We simply just put this right here, and the for loop will now just run amount times. Okay, cool. Now we want this dice to be random. It's a random 6-sided dice. And so let's say random index equals int.random 6. But this is just kind of like bad coding convention because we truly, if let's say we can, like, it doesn't scale. And why? Because let's say dice, right? Dice can have, dice can have 12 cases. Dice can have 3 cases. Like, we want to be able to kind of go with all the different cases that we have for dice. So let's add 2 things to this. One, let's make it one, I believe I just do this. It's case iterable. What does case iterable do? So if you do the option look click, it will show you, but essentially it just allows us to have like a count of what cases do. So now I can actually make some like proper code that scales with how many sided dice I want. So I can do dice dot value dot all cases, right? And then just count that. And so like going back to just like the importance of kind of knowing what these like previously installed Swift functions, right? Now I kind of made some code that does scale with with the code. Because then if I was to put 6 from the get-go, the main issue is I would always have to kind of change it. Like let's say I want to do a 12-sided dice. But now when this moves, like when if this was to increase, right? If this was to kind of go to 20 to 4, I don't have to change this code at all. The code is perfectly like fine. And then from here, right, we want to add dice to like every dice that they kind of imagine this random is the roll. Every dice we're re-rolling, we want to append a dice, right? And given that we initialize this array as a dice, we had to create an instance. So this is us creating an instance. Once again, if you're confused about the word instance, objects, classes, don't stress. These are just very like when you take classes in computer science, most likely you're gonna kind of gain an understanding of these topics. Dice.value, all cases, and then a random index, right? And then if you're kind of curious, like what all cases does, it says right here from the case iterable, it just simply returns an array of dice values. So if you're curious, option click, you can kind of see that the cursor changes. Another cool thing is command click. So let's say I don't even know what dice is, and if it's within the code, if I command click, boom, it takes me to this file where it is. So if you're working with a new code base, so like personally, I use this a lot. If you're working in a new code base and you're like, okay, I don't know what dice is, like what is dice, what is player, you can simply just do this command click, and then it will show you the documentation of hey, like okay, and this is where it is within the file, you know, this is what it does, and then sometimes like people will have some more stuff like explaining what things are. So kind of just like a neat trick that I learned like while doing iOS development. Not cool. Now let's do let points equals. Hmm. I think we need to make a method. So right now we simply just like because dice aren't like a number, we kind of need to make another method that calculates the dice for us. We don't want to be able to we don't want to like do it within here. I think it might be messy. So let's just create another helper function. So let's do private func. And going back to what Justin said, right? If you have the private views, private func is the same thing, right? Don't want, we don't want other other things outside this class to access this, right? This is simply just a function to help us with this function that we will use outside. And I'll kind of show you later. And one thing too, right, is as you kind of seen, we have points. I want to do points equals to it's plus equals. No, sorry. I want to do let points equals to tabulate score. as you kind of see, right, it's gonna give us an error. Well, you have points, but then the issue is this is a void. So how do we indicate in our function that we want a return of any type, right? We simply just do this little arrow. So you would hit like next to the plus button, that, and then create a little alligator, and boom. And now it's going to give us another error saying, hey, we need to return int. So for now, I just type in return 0. But it's simply just a simple like sum function, like summation function. So we just add var sum equals 0. And then, just picking up elements within our sort of if you want to make a for loop that actually goes inside the arrays and access things, you simply just do for dice in dice, let value. So right here, right, the difference between this for loop and this for loop right here, right, is this for loop will go into the count, but this like will go into a certain number, right? So that one's kind of like the idea of like for I in range 10. But then this one right here, right, this for loop will actually go inside the array itself and actually pick up elements from the array. So right here, right, we have for every dice, each dice is going to be a dice object, or yeah, and then we can simply just do dot value, right? Because once again, going back here, you kind of see that value is a dice value, and if we pick so with the help of the string, right, these are some raw values right here. Not only did that help us with picking up the dice images for our or for our dice view, this is actually helping us with our numbers, right? Because now I think we could do a neat trick where we do dice value and do type in right here numerical value. So this code right here essentially, oh, let's see what the issue is. Dice value has no value numerical. Okay, I might do something a little messy. So give me 1 second. I might just do raw value, and then I believe I can turn this into an int. Oh yeah, that works. So yeah, now like because if we type in raw value, right, this will return a 1. And then what I'm doing is just turning that 1 and like turning the string 1 into a number 1. Cool. Yeah, it's freaking out because I'm not actually using the variables. So this is what I'm talking about where it's like if going back to this sort of like omniscient, like the reason why I'm omitting something is like the IDE tends to like say, hey, you're not using these variables, so why are you even declaring them? Like, why are you initializing them? And then they're freaking out. All right. And then, it was a while ago. So there is this one special rule, right? As you can see, if we hit a 1, right? If the number we get, one of the dice values is a 1, it doesn't matter how much you get. You can get like 99. And if it's like a bunch of fives and fours, if you just get 1, all the points that you got will be 1 for that turn. So if value is equal to 1, then you simply just return 1. Else, sum plus equals. So yeah, just plus equals, boom, the value, and then you would return. Oh, sorry, you would return sum. Now a bunch of this stuff should not freak out. Oh, okay, and then just forget about this right now. But this is gonna be a like weird fix. I think this should work. Kind of going back to what I mentioned about like nils, right? So if something's nil, it needs to be unwrapped. This is something I'm wrapping. Don't worry about that for now. It's a very like complicated topics about like optionals and whatnot. All right, cool. So now you just simply get the current player. So then you do current player, right? And then remember what current player does. Current player is our getter that simply just oh, I think this is correct. Current player is our getter. Yep, yeah, current player is our getter that simply just returns which the player is right now. We do dot points. Let's see what is points. And then because the like in theory you would add some sort of like method, right, within the roll dice. I think for now if I leave this should be fine, but we could just add like we don't have like a winning screen, so it'd take an extra probably like 20 minutes to add the winning screen and add more logic for that, right? In theory, in roll dice, you could probably add like a check, right, after the roll if you got 100 or past 100. But for now, I'll just leave it like this. So cool. Okay. We have a lot. So yeah, now we have our game manager. So in our main Swift view, we want to kind of create this variable game manager. So once again, we don't want anyone to kind of access this. We want this game manager to be accessed with us only. We just do private var game manager equals right here a new instance of the game manager. So now we just created a new game manager. But there's one thing kind of missing. So let's just mess around with this for now, right? And I'll kind of well, yeah. Okay, let me go through everything first, and I'll kind of show you we are missing like two crucial things. And because we're missing these, you're gonna notice that our stuff is actually not gonna reflect. Like so, all a lot of things are not gonna translate, even though the code is in theory working. And I'll kind of show you why. But for now, right here, boom. Instead of dice.view, what we can simply do is we can just add that like now because we have our game manager that controls our state, we can simply do game manager dot dice. Boom. Oh, and then little error. So right here, now we're gonna have data that is dynamically changing. Where is something that's sort of static? Oh, right here. So another sort of static thing, because right here, let's change that to player one. Oh yeah. Nope. Player one, and then just type in points. So right here. And then right here, we go call our game manager again, grab our player two, grab his points. And now you're kind of seeing that these are done statically. Another kind of cool thing too is you can actually create a sort of like you can kind of create conditional views. So like as we kind of noticed, right, you want these to be flip-flop per the player's color. So what we can do right here, right, is foreground. We can say if game manager dot current player's turn is equal to dot one, then we do blue. Or actually, to make it more accurate, we do game manager dot current player's color, right? And then that color would be whatever it is. Else, you do black, right? And then this little, wait, hold on. I don't think that one. What's the little error? It's hashable. Oh, what's the freak out? Background color song, points. Okay, I'm gonna let me try it one more time. Current player, that one, do this. Let's just do this for now.
Oh, Dylan, it's current player turn.
Oh my God, thank you. Okay, thank you, thank you. Current player turn to equal one. Thank you. Okay, and now this should be fine. Current player, the color. And I think as you're noticing, right, this is kind of like another way to do an if statement, right? So right here, this is sort of our case. And then you can kind of imagine after you just add the little, like this is a tertiary, you add your little question mark. Right here would be, okay, if the case is true, right? So if it's equal to one, then we use the color. If not, this is our else case. By default, we use black. Gonna copy the same code to down here. And then instead of one, let's do two. And now I think it should reflect in the UI. Yes, perfect. All right, cool. So we got that. Let's see other sort of stationary. I think for now, these are sort of the kind of like static things. Okay, cool. And now we need to add sort of our effects here, right? So as you kind of notice, with the button, if you see, there's two buttons, right? There's one right here, which is, you can tell top bar leading. So one right here, and then we have another button kind of like done right here. If we hit this, then we don't care. Like we don't care what gets added. Like we're not adding more to the dice. But right here, if we were to hit done, then that would indicate that, hey, like, okay, we are what's it called? We are oh sorry, yeah, we are adding our dice. So now we gotta do one thing. We have to add in a variable called game manager, right? So we do var game manager equals type game manager. And the thing is, I think like for example in Cupstart, a lot of students get sort of lost because what they end up doing is they create another instance of game manager. And the issue is, let's say like we did what we did previously, where we did game manager equals game manager and add the parentheses. What happens when we add the parentheses is we're creating another instance. These are two separate game managers. So when I click the picker and I add 10 dice to the array, it's not getting added to the same array that's over here in this game manager. So that's going to be a problem. And you can kind of see earlier, right? This was kind of giving us a bug saying like, hey, like there's no game manager. So we're going to create the variable game manager. Sorry, a variable, yeah, game manager with type game manager. And then like it's gonna complain like, hey, right here, we're not we need you like to pass it down. And then the reason why we want to pass down this game manager is because we just want one source of truth. We don't want to have two different game managers, and now we're not able to kind of interact with each other. So oh, yeah. So this is giving me error right here, right? So now I need to go over here and then add game manager and then add in the game manager. So now, like within our two views, we have the same game manager, and all the information within that, like within the class, is not shared. It's not gonna add to a different array. It's not gonna add to different things, right? If the best way to kind of think about it is if we made a new instance here, right? If we add the little parentheses, you're having two different games happening at the same time in your app, and they're not connected. The data is gonna be all weird and wonked, and you're not gonna like this is not gonna work. So it's a very common thing. So right here, right, when we add the var, it just allows this view right here to just demand like, hey, we want this variable, and then now we're actually able to pass down this variable into this view. Cool. Okay. And then going back here, right, we have a button, and usually the button has two properties, the label and the action. So right here, this done part is the label. And now right here, the action is dismiss. One more thing we want to add on top of this dismiss is we want to add our game manager dot roll dice amount. And where are we getting this amount from? Oh, right here. We have a state private var. Cool. So now num of dice, right? So now when I hit this done button, it's actually doing the rolling. And I wanted to show earlier too, right? When we do our private method, if I was to hit this and type in, oh, I spelled game manager wrong. If I hit tabulate, it will pop up, but the idea of private is that we don't want this to activate, right? We want to keep things separate. We want our roll dice to be able to be used by the views, but we don't want the roll die like the views to be able to use this private function right here. So there's kind of some like coding conventions. All right, oh, so now hey, everything seems like it works, right? We implemented the game manager, we added all of our functions. Okay, so if I was to hit take turn +4 and then hit done. Okay, so what's going on? I'm okay, let's try again. 10. Oh shoot. I think
Wait,
my game's
you need
no,
your
so
at
yeah,
state.
I'm transitioning. So I know what the problem is. So there's two things I'm missing. So previous at the UI, we have this thing called at state, right? And at state is a reflection So one thing we can do is actually go to our manager class right here and add this observable. Dude, so we hit observable, and what observable is essentially a macro, and a macro is just a bunch of code that helps makes a code. So we hit observable. If in turn if we didn't want to use observable, we would have to hit add state for here, right? So there's sort of like two different ways to do it. We would do add state or do observable. Because what was going on earlier was because we didn't have these keywords, what was happening is that our data wasn't getting reflected. So as you kind of seen earlier in our thing, like we weren't changed, like our scores weren't being updated, our players weren't switching. So okay, let's see now if this is actually working. So keep in mind, right? If you want to be able to yeah, keep in mind that you need if you want to show reflections, if there's certain variables that you're using and you want to show the reflections, you need to add these sort of keywords to it. And I think I'm missing one more keyword if I'm correct, but I'll get to there when I see it. So now let's see if it works. Hit two. Okay. So what was the main thing we were missing? We were missing this at observable keyword, right? And then just to yeah, so what this observable keyword is adding is it's giving like it lets all of our variables be able to be perceived by the UI, right? So every change that we're making is now being reflected. Before we didn't have that, and now as you saw earlier, I wasn't able to show the different changes. But now, yeah, let's do four, hit 17. I think the only thing that is not working is this guy, but just a little, don't know. We're already at like 9 o'clock, so I don't know how I feel like debugging. I think, hold on. Let me test out one thing. I think the only thing I'm missing is the turn switching. So let's see. Hit three. Okay, yeah. So what the actual issue is in my game manager, right? So this is some a little example of debugging is we're not switching. So that's kind of the only thing is after every like roll, right? We just have to do current player turn is equal to current player turn, right? So essentially, just kind of using little Swift to help me out here. What they're saying is current player turn is equal to one. If equal to one, then go to two. If not, go to one. Cool. I think now you're going to see that the colors over here are going to change and you're going to see the points be different, right? So let's just go 10, hit 10, get that. Okay. And now on, boom, right here. So this is already a good sign that there's showing reflections. You have player two, it's the color blue as our logic right here. This is black. And now if I go hit five, we should, yeah, we're actually seeing the changes. Okay, and let me see if I can get the rule that we added. So let's see if the one's working. So let me just roll another 10. I'm bound to get the one. Oh, right here, right? It didn't add all this up. I got this one. Let's okay, remember the score is 22. So let me roll another 10. And yeah, but it only added 23 because I hit one. So yeah, our game's working. Yes. And just yeah, I think this is about it. Yeah. So yeah, thank you for. I think is there anything else I need to add, Justin? Or I think that's about most of the game logic.
Yeah, I think that's about it. Yeah.
Yeah. Yeah. Sorry that this took a very long time. The thing is like Swift is a very intricate language, and Swift UI is also very deep as you can see. There's a lot of different elements, and like the more it's similar to just like I call it like life. The more you work with Swift UI and discover new things, the less you know. So there's just so much that you can do, and like so much different customizations, like formatting. There's certain beliefs and like you get into the navigations and stuff. Like navigation, oh, that's another different ballpark. So it gets tough. But yeah, we really appreciate everyone coming and being very patient with our, like technical difficulties. Um, and yeah, hope to see you guys what, this Saturday, 3 more days now, I think, right?
Yep. Yeah. Thank you guys so much for staying till the end. We'll be sending the recording later this week. Um, M asked, what is the workshop schedule for this week? We'll be announcing that closer to the event, but just expect to have more announcements on Slack and also on the website. Yeah.
And
Thank
uh,
you guys.
Teeman said that could you print some variable out like dice number things like that, or in iOS dev we do not usually print things out. You can you use the print method to print things out, and when you run the game actually on the simulator, so you see that play button on the top, you run it on the simulator, you could it the print statements show up in the console. So I think Dylan can demo that.
Not returning int, but I can kind of work through that. So let's do our toolbar right here. We're calling that. Then we can do print game manager dot tabulate score, right? And then you kind of see that because it's private, it's not gonna, oh shoot, see, it's giving me this private protection. Like, so I can add it. It's freaking out because once again, you're not supposed to be able to use it outside, but I'm going to change that. So now it's actually usable. And then if you kind of look right here, this is the sort of preview, right? So I'm going to do two things. I'm going to add one more sort of print statement, right? So this is going to print dismiss. So pay attention to the kind of the bottom corner right here. If I hit, boom, I think prints out dismiss. And in theory, I think if you do hit 5, it will print out what I'm returning. So because our rule, we're returning 1. That's sort of printing values in Swift. But like if I like once again, you would need something to indicate. So I wouldn't be able to do zstack and type in like print hello, I think. So yeah, it's freaking out because as you can see, it's not conforming to the view builder. It's not conforming to Swift UI's like semantics. So yeah, any other questions about this? And I think for workshop schedules, most of the workshops are going to just be on Saturday after, I believe, after 11. So I think 11 is when most workshops are going to be